Hi everyone, in this video we will understand, does the probability depends on the sample space or not. Let's suppose a person P1 has taken a sample space S1 and person P2 has taken it S2, and the probability that comes out is P1 and P2. Are they equal or not? We will be checking this with the help of an example. Now the example says that you are having a box that contains tags marked from 1 to 3 to n, and two tags are chosen at random. If the tags are chosen without replacement, then the probability that the numbers on the tags will be consecutive integers. So we have to find the probability that the cards should be consecutive. We have to find the probability of getting these consecutive cards, right? So we are having 1 to n cards. Now I will be solving it by taking two different sample space. So in the first case, let's suppose you are having n cards. Now you have to choose two cards. So how can you choose? We have a formula NC2. It says that you are having n cards and you are just drawing two cards from it simultaneously. So let's suppose in the first go, the card that comes out is 2, 3, and let's suppose another person chosen the two cards and they comes out to be 3, 2. So they will not consider different, they will consider that same, because when you put the combination formula, then we don't care about the arrangement. So in NC2, what will be the sample space? The sample space we will consider as S1. So it will be like this: 1, 2, 1, 3, 1, n, then 2. We will not put this 2, 1 because 1, 2 and 2, 1 are same. So 2, 3, and we also don't have 1, 1, 2, sorry 2, 2, 3, 3, because we are doing it without replacement. So if you have chosen 1 and you wanted to take out another card, then you don't have a possibility to choosing the 1 again. So that's why we don't have the x, x case, right? So our sample space will not contain this 2, 4 like this. So our sample space is like that only. We have an ordered pair only, right? And now we have to choose the consecutive cards. Now we have to, what are the favorable case? So the favorable case like this: 1, 2, then 2, 3, then n minus 1, n. So how many numbers are there, like what will be their counts? So just see that when you are choosing 1, then with 1 there is one number is coming that is more than, like the value of it is more than 1. So with 1 the 2 is coming, with 2 the 3 is coming, with n minus 1 n is coming. But we are not going from 1 to n. We are not taking this 1, because if we are taking this n, then the number that comes after this should be n plus 1. So from 1 to 3 to n minus 1 to n. So we are just going to this point. When we are selecting this, then it is automatically coming. So how can I select? So I will select from n minus 1 C1, right? I have selected the first card and I don't need to select the second card. So I will simply say 1, right? Because when you select 1, then the pair that it will make is with 2. And in the similar way, when I select n minus 1, the pair that it will make with is n. But I can't select n because we don't have a number n plus 1. So the numbers of favorable case is n minus 1, choosing 1 and into 1, then upon nc2. So it will be, so it is like this: n and nc2 upon 2 factorial. So the answer will be 2 raised to n, right? Now taking the different sample space, when let's suppose you selected 3, then the consecutive possibility of choosing two number can be 2, 3 and 3, 2, 3 and 3, 2 also, right? This is also a consecutive number and these are also a consecutive pairs. Now let's suppose if the replacement is allowed, If the replacement is allowed, then you can, and how many ways you can select two cards. So let's suppose you wanted to select two cards. Now for selecting first card, how many possibilities you are having? You are having n possibilities, right? Because you are having n numbers. Now for the second card also, you are having n possibilities, because when you selected, let's suppose you selected this one, then you still have the, you replace it again. Let's suppose you took it from this bag and now you are again putting it back, so you again having the n possibilities, so n cross n. So with replacement, you are having n square possibilities. So n square means what it can be look like. So the sample space is S2, it look like this: 1 comma 2, 1 comma 3, sorry, 1 comma 1, 1 comma 2, 1 comma 3, like this, and 2 comma 1, 2 comma 2, 2 comma 3, right? In the first sample space we don't have like this and this kind of thing, x comma x we don't have, and when we are selecting this 1 comma 2, so we are not taking 2 comma 1, right? But since in this question we have to find the answer without replacement, so we have to remove something from S2. So what we need to remove, we need to remove this x comma x pairs. So our number of how many pairs are there in this is, like, we have to count the x comma x pairs. So it is like this: 1 comma 1, then 2 comma 2, then n comma n. So how many pairs are there? N. So our sample space will be, how many numbers are there in our sample space, how many pairs are there? N square minus n, right? Now the favorable case differ here. Why? Because initially we are having 1 comma 2, 1 comma 3, we are not having 3 comma 1, 2 comma 1, but we have, when we have 1 comma 2, then we also have 2 comma 1, like this. If we have 3 comma 1, then I have 1 comma 3. So the favorable case just double the number of favorable case when we are having a sample space S1. So our probability will be, favorable case counts is 2 into n minus 1, that is, this is n minus 1, and when we are taking its reverse, then it will be 2 times of it, and then the n square minus n. So the answer that comes out to be is 2 comma n. So you see, with sample space S1 and S2, our answer is coming same, 2 upon n, 2 upon n, right? Why it is happening? So can we conclude that the probability does not depend on the sample space? No, because when you are taking a sample space and probability is the, let's suppose probability P1 is the ratio of favorable case upon total case, and P2 is F2 upon T2, right? So whenever the ratio is same, in spite of having the different sample space, the probability will become same. So it is not particularly, it is not in general that in each and every question, whenever you are taking a different sample space, then the ratio will be same. It is happening with some particular question, and I have given you that question. So I will conclude that probability is indeed dependent on sample space, right? Now we have not covered the second case, that is with replacement. So with replacement, our answer will be like, the sample space, the number of element in our sample space was, when there is no replacement, then n square minus n, right? But we are having a replacement, so we are also having 1 x comma x pairs, so we are not removing this n. So the number of element in our sample space will be n square, and favorable case will be remaining the same, 2 upon n square. So this will be our answer for with replacement, right? So thank you, that's all for the video.